Hi, my name is Roshan Kumar. I am from Jharkhand. I am pursuing Master of Science in Physics from NIT Durgapur. My topic is kinematics. It's a branch of classical mechanics that describe the motion of points, objects, and system of groups of objects. Okay. Now I am starting from point general definitions. General definitions. Okay. Kinematics topic position and displacement and distance. Okay. uh, let us assume that particle is placed here. Okay. How I can define its position from I will see this graph and say that particle is located in one point. Okay. Now let's assume that particle moves from here to here. Okay. From point A to from point then to point B. Okay. And its location will be 2 to. Okay. Now we will come to displacement of this particle. Okay. So what will be displacement? Final position, final position to initial position minus initial position. Okay. What is the final position? 2ik plus 2jk and ik plus jk. Okay. Now what will be the displacement? Ik plus jk and its magnitude will be root 2. Now come to the distance. Now come to the distance. Total part covered. Part covered by the objects. Objects. Its distance. Okay. It's a scalar quantity and it's a vector quantity. Okay. And what will be distance from point A to point B? It will be from point A to here 1 unit and here to here 1 unit. Okay, total 2 units. 2 units. Okay. Now we will start. Now next point is rate of change. Rate of change. Okay. Displacement and distance. Then what will be rate of change of displacement? Rate of change of displacement will be velocity dl by dt. Rate of change of displacement with respect to time. Okay, it will be velocity, and rate of change of distance with respect to time is speed. Speed and its velocity. Okay. Now, what will be average velocity? Average velocity will be total displacement upon total time. Okay, and it's instantaneous velocity. Instantaneous velocity and its instantaneous speed. Speed. Okay. And what will be average speed? Average speed will be total path covered by objects total time taken. Okay. Now, what will be acceleration? Uh, what will be acceleration? Acceleration will be rate of change of velocity with respect to time. Okay. It's also instantaneous acceleration. Instantaneous acceleration. Okay. Then what will be average acceleration? Average acceleration is similar to VF, final velocity, to initial minus initial velocity, total time taken to achieve initial velocity to final velocity. Okay. Now what will be rate of change of angular displacement? Okay. Angular displacement. What will angular displacement? Angular displacement is theta. Okay. Rate of change of angular displacement with respect to time is what? Angular velocity. Okay. Then what will be average angular velocity is equal to final angular displacement minus initial angular displacement to taken total time to achieve initial angular displacement to final angular displacement. Okay. Now angular acceleration, rate of change of angular velocity with respect to time. Okay. And average angular acceleration will be final angular velocity minus initial angular velocity time taken to achieve initial angular velocity to final angular velocity. Okay. now let's take an example. Okay. uh, Particle is moving with velocity what 6 tik plus t square j cube. Okay. Now we have to calculate total displacement. Total displacement at t equal to 0 to t equal to 1 second. Now we have to calculate total displacement from t equal to 0 to t equal to 1 second. Okay. Now what is the formula of angular velocity? Velocity. It will be rate of change of displacement with respect to time. Okay. Then we will integrate from time range of time what 0 to 1 second. Okay. Okay, plus 6t square j k integrate with respect to dt. Okay, 6t square. Okay. 3 ik plus 2 j k, and its magnitude will be 30. Okay. Then we are taking a second example. Wheel start rotating with angular velocity pi t. Okay. Then we have to calculate at what time it will complete its first revolution. Okay. At what time t it will complete its first revolution. Okay. We know that angular velocity is equal to what? Rate of change of angular displacement with respect to time. Okay. Then we will integrate d theta 0 to 2 pi and okay 0 to t, because we have to find t for its first revolution, time taken to complete its first revolution. Okay. and 0 to 2 pi we are integrating angular displacement because and will has 2 pi to 2 pi it's angular displacement. Okay. Okay, because omega is angular velocity is what, pi t, and we integrate pi t. Okay, so then it's come pi t square by 2, and 2 phi is equal to pi t square by 2. Pi cancel out and t square equal to 4, then t equal to 2 seconds. Then in 2 seconds it will the wheel is complete its first revolution by rotating with a angular velocity of pi t. Okay, now let's come to the point summary. Okay, what is discussed? Velocity, which is what, rate of change of angular displacement with respect to time. Second, speed, what, rate of change of distance with respect to time. Okay, and average velocity, total displacement upon total time. Okay, and average speed is what, total distance covered upon total time taken. Okay, and the magnitude of velocity is equal to speed. Okay, u then. Okay, in speedometer we use angular velocity and angular displacement to calculate speed of the car, and many things we use angular velocity and angular displacement, like we use displacement and velocity, instantaneous velocity in projectile motion, and many things. Okay, thank you.